Hi and welcome to this video. I'm going to show you how you can use vulnerability intelligence from Flashpoint's VulnDB to perform threat-informed prioritization for your vulnerabilities as soon as they're discovered in AttackForge. Flows is a new module in AttackForge which is purpose-built for automations and integrations. This example is available on our support site, so you can follow it there as well. But also, if you head over to our GitHub Flows repository, there is a link there to the Flashpoint VulnDB flow that you can download and then import into your AttackForge to get started fast. So, for those of you who are not yet across what Flashpoint's VulnDB is, it's really a vulnerability intelligence service that is available, and it's actually one of the best ones we've ever come across here at AttackForge. So it has a ton of information that is available for nearly every vulnerability out there. So we can see at the moment 392,000 vulnerabilities that we can retrieve a lot of rich information about. As an example, if we look at Log4j, we can see some key information here that's going to help us with threat prioritization. Is it a size of kev? Is it a 0-day? What's its relevant scoring? Ransomware likelihood? EPSS as well. Information here that's going to help us classify this vulnerability. And also every affected product as well, and all of its affected versions. Which is again a ton of really useful information. We can see all this other information as well relating to packages, and then all the industry references that we would need as well to help with correlation. So there's a ton of information within the VulnDB service itself, and there's a very rich APIs that allow you to query to extract all of this information depending on what use cases you have. So let's see this flow in action. So if we go to a project on AttackForge, we're going to go in and create a vulnerability. We're going to start by selecting a write-up. So I'm going to search for an XSS we found, and then go ahead and assign some affected assets. Now, let's go in and save that vulnerability. And we'll notice we saved it as a high. So we'll give it a second for that flow to run. And immediately we'll see that it's now dropped to a medium. And if we scroll a bit further down, we'll notice there's been a threat score applied within this custom threat prioritization section I've created. Now this score, is saying it's a 50 out of 140. Now that probably means nothing to you or anyone watching. This is completely custom. This is something I've set up that is personal to how our organization does threat prioritization. And that's one of the benefits of using flows and being able to leverage these different vulnerability intelligence data sources. Let's look at this a little bit deeper to understand actually what's going on behind the scenes. So within the Flows module, which is available under integrations if you have access to it, we can see I have a flow here to add that threat-informed prioritization to the vulnerabilities and go ahead and add that custom scoring. And this is really going to help us with understanding exactly which vulnerabilities to focus on. So instead of just having the pen testers provide their input into what they believe is a score for the vulnerability, we can enrich that information with data, in this instance, coming from Flashpoint's VulnDB. And that's going to help us make sure that we are actually focusing on the right vulnerabilities first when it comes to remediation. So let's go in and open this run. This is for that vulnerability we just created moments ago. And we can see there's 3 actions in this flow. So the first one is to go and retrieve a VulnDB OAuth token. Now that's required as a precondition to communicate with the VulnDB API to retrieve all of that intelligence data. The second action is there to retrieve threat intel information from VulnDB. So this is where we're now going and querying the VulnDB API to then get that information back so we can then process it. The last action is taking that information from VulnDB, going through a completely custom prioritization workflow, and then ultimately coming up with a custom score, which we saw on the previous page was that 50 out of 140. Now, if we click on HTTP, we can then see more information of what's actually happening. So at this point, we're going and fetching data from or retrieving a token from Flashpoint's API. We can see the body and request headers that were sent, and similar the response headers and response body, including the access token. The logging is there to help with debugging. In case there's any issues or troubleshooting, you can add logging using AFScript to help you with tracking what's happening in your flows. Coming into the second request, we can see there was a subsequent request then made to Flashpoint's API to then go in and retrieve some information about this vulnerability. I was querying based on CVE, but again, they have a very sort of vast array of APIs there to query based on all different aspects. We can see this was a successful request. It's come back with a 200. We can see what we actually had sent across again to their API, and we can see the rich data that's come back as part of that API. So here we can see there's quite a lot of information that we're going to be really taking advantage of as part of that next step in our flow or next action. So sort of looking at the last action, we can see the input into this is now information from VulnDB. So we now have all of this rich information about the vulnerability itself. And we also have the data from the AttackForge vulnerability as well. So we're going to be combining the two in order to really perform our threat prioritization. And then we'll go ahead and update the vulnerability in AttackForge to set that score and adjust the priority ratings as well. Okay, so let's dive into this a little bit deeper and see what's happening in each of these actions. So we're going to open up the flow. And again, we'll notice that I've set it up to run on a vulnerability created event. So this is going and performing this prioritization as the vulnerabilities get discovered in AttackForge, which is great because that means you're practically getting a real-time feed of prioritization, based on what's happening out in the world as your vulnerabilities get discovered. However, if your use case is again, reliant on other preconditions for your vulnerabilities, you can always build that into your logic, either in the created event, or it could be based on a vulnerability updated event. So for example, only go and perform this prioritization after the QA has been done on the vulnerability, just in case certain aspects of the vulnerability change that could affect how that prioritization gets done. But in this case, we're going to stick with vulnerability created in this example. So in the first action, we can see that we need to go in and retrieve a VulnDB OAuth token. Now, again, using their API documentation, we know that it's a post request to this particular URL, and the request headers are going to be really just setting the content type to application JSON. Now, if we open up secrets, we'll see that there are a few secrets that we've created that we'll be using as part of our request scripts to go out to each of these different APIs. One of those is the AttackForge self-service API key. We're going to need that in order to update the vulnerability with this, again, the new threat score and any other changes. But also having the VulnDB client ID and client secret, which is there as part of those OAuth tokens to then again retrieve the relevant credentials that we'll need to then make subsequent requests to the API. Once those secrets are set up, let's take a look at the request script. So here, what we'll notice, again, I've set this up to perform this based on CVEs, but again, there's many different ways you can set up your custom threat prioritization. And what it's doing, it's going and fetching the CVEs, from the vulnerability if they exist. And if they do, we're now passing that CVE into the next phase of this flow. And we're also passing along the vulnerability data. Now, what you'll notice here on the right-hand side is what we call a test context. Because this is a flow that we're building, it's not relating to any specific vulnerability itself. It's here to give you an idea of this is what you would get when a vulnerability gets created in terms of the fields. And we've got information here relating to vulnerability, information about the vulnerability itself, its affected assets, the projects that it's linked to, information about the write-ups, and a whole host of information that we can take advantage of. So this is now that initial context that's going into our flow. On the left-hand side, this is all AF script. So if you're not yet across AF script, we highly recommend to go to our support site and do a little bit of reading about what AF script is and how it works, as this is the scripting language that we use for flows. And so here what we can see at the bottom is that it's going to then also return a request body. So this is going to be the body that's going to be sent out as part of that first request to retrieve a OAuth token from the VulnDB API, and we're passing in the client ID and client secret that we've got set up, as well as the grant type. Now let's take a look at the response. So the response will come back with some information. Hopefully it's going to have an access token. So the response context is an object that contains a status code. So this is the HTTP status code coming back from the VulnDB API, as well as any headers or response headers and response body as well. So here in our script, we want to firstly make sure that the response is coming back in an application JSON format. That way we can then hopefully extract the access token from that body. If not, it's going to abort the flow at this point and sort of log an error. If that access token's there, then we're going to now, as part of our data, set that access token and pass that along into the next action on this flow, which is then going to use that token to retrieve data from their API about this vulnerability. We're also passing along the CVE and the vuln that was originally set in the request, on the previous screen. So that information we're going to eventually need in the last action of this flow. So now let's open up and take a look at the second action. So this is where we now want to make a request to the API to retrieve information. This is the VulnDB API. We know it's going to be a GET request based on their API documentation. And again, we know that they're expecting the request to be in a JSON format, so we can go ahead and set that content type header. But the URL itself is not statically defined, which means the URL will have some aspect of the vulnerability properties that we're querying for. In this example, it's going to be the CVE. but again, depends how you've set up your integration. So for that reason, we need to set this within the request script itself. So let's open that up and take a look. And so here we can see that there's some checks being made. Is there a access token? Do we know the CVE? And do we have the vulnerability data from AttackForge? And if those conditions are true, then let's go in and make a request to VulnDB's API to then find some vulnerability data based on that CVE. And again, we'll supply the this is where we can add additional headers as part of our request. So in this case, go and set the authorization header with that token. We're going to also continue to pass our CVE and vuln information because we need that in the last step of this flow, again, so we can actually apply all this prioritization. So now let's look at the response script for this action. And much the same as the previous one, we're going to do some checks to make sure the data's come back in a JSON format, and if so, that there is at least one vulnerability that's come back. So there is potential that multiple might have come back, and you may have your own logic for how to pick which vulnerabilities you want to use. But in this case, I'm just going to pick the first one in the list. And yeah, so based on that, assuming we have at least one vulnerability that's come back, we're going to now pass along the CVE, the information about that vulnerability that's come from VulnDB, as well as the vulnerability from AttackForge. So now we'll have all of the information we'll need to actually apply some completely custom threat prioritization. So let's open up the last action in Flow, and we'll see that it's going to be a put request. Now this is a request that will end up going to AttackForge's API, and we need to make a request to the vulnerability, update vulnerability API itself. So that's where we'll need to open that up and take a look. And we'll see that that API requires passing the vulnerability ID within the URL itself. So that for that reason, that's why we are going to go and set that URL inside the script itself. But we know it's a put request, again, based on that API documentation. We also know that AttackForge expects a JSON payload, so we can set the content type, and it's also expecting the self-service API key, so that way we can authenticate against the API itself. And again, we're using the secrets for that. So let's open up the request script. And this is really where all the fun part actually happens. So what you'll notice is that there are sort of two functions we've created, which one is used to go and score the vulnerability, and then the other one is there to convert the score into an actual priority itself. So once that's done, we can then go in and update the vulnerability in AttackForge, and we're going to set the URL here with the vulnerability ID. We're going to update the priority of the vulnerability, and we're also going to update the threat score. Now the threat score is a custom field I've set up in AttackForge. So if we open up the administration settings and open up vulnerabilities, we'll see that I've created a section here on my vulnerabilities called threat prioritization. Now I've set this up as a single field, which is a input field that has some score, and that's what we were seeing when we were viewing the vulnerability. You can do this in any way that you want. You're not limited by having a single field. You can get as creative as you need to make sure that you have the data that's going to help you filter, sort, query, and really just focus in on the vulnerabilities that are most important to your organization. But in this example, because I'm only updating one field, or that's going to have the score in this instance, I need to know what this key is, and that's what we're going to use as part of this update. Looking at the first function, which is there to calculate the score. So let's go in and actually take a look at that. So I've set up for my organization, I've set up a completely custom scoring and threat prioritization process, and I've based it on a score out of 140. Now there is some method to that which is probably a little bit out of scope for this video, but you'll go through and see how that scoring actually stacks up. But the idea is, the higher the score, the higher the priority. So we can use the numbering system to really sort of focus in on which vulnerabilities are actually a higher priority right now to go in and hopefully start remediating. So one of the things that I'm looking at as part of my threat context is it on an internet-facing asset? So what I'm doing here, I've actually got another function here I've created called is internet-facing, and if we have a look at that, we're relying on data from the asset itself. So I've went in, set up my asset schema in AttackForge. One of the fields as part of my asset schema is whether the asset is internet facing or not. And in this instance, if it's an internet facing asset, then in my view, that creates a higher risk profile, because potentially if it is attacked, it's going to be much easier to be attacked. So for that reason, I'm going to factor that into my scoring as we go through and prioritize the vulnerability. Now, this is just one factor on the asset. You could have many other factors there. So again, you're not limited by even just asset data. It's really whatever data you have in AttackForge or even outside of AttackForge. You can go and make additional requests against your CMDB or any other external systems that has important information that needs to be fed into your threat prioritization process. But again, for this example, I'm keeping it simple, and we're just using this one aspect of the asset. So let's come back to the top. So once we know whether it's an internet-facing asset or not, we can then start to factor that into the score. So we can see here that if it's internet-facing, I'm already going to allocate a score of 10. So now we're looking at CVSS. Is the CVSS score 8 or higher? Is the threat easily exploitable? If so, I then want to go in and start adding more to my score. Is there any user interaction that's actually required? Again, that's a interesting factor in terms of how this vulnerability could potentially be exploited. Separately, is there a public exploit available for this threat? So if there is, again, the likelihood of this being exploited goes up. So we can account for that as part of our scoring. Does the threat require any configuration changes? So again, that's an important metric to consider. Does the threat grant unauthorized access? So again, we're looking now into the weeds of what can this actual vulnerability end up doing? Is there a disclosure in the wild? Is it wormable? If as an organization, if I'm particularly concerned about vulnerabilities that could be part of worms that are then going to propagate through the network, or it could be is it a virus or malware? If that's something that I've particularly concerned about, I can build that into my threat score. Any of vulnerabilities that potentially meet that criteria are going to have expedited focus to make sure that we address those ones first. here is the POC public. So again, can everyone, theoretically, can anyone go in and know how to go in and exploit this vulnerability? If so, and we can see now how we can start chaining this together. There's a public POC. This thing is a virus or it's wormable. It's in the wild. People know about it. It's on an internet-facing asset. It's all stacking up now to be a very serious issue that we need to look at. Now, separately, you could also consider the flip side of this. If the vulnerability is not meeting any of these criteria, maybe it doesn't need to be as high as the rating that's coming from the pen testers. That was the case in my example we created. I set the vulnerability to be a high, and it actually got downgraded to a medium. So again, we're using this information to try and create some level of normalization around what is actually considered to be a real threat to the organization. So looking at this again, is there a patch available? What is the social risk score? Again, another interesting metric to look at. Could it be used in a ransomware attack? What is the likelihood there? Is it a known exploitable vulnerability according to CISA? Again, if we're focusing on CISA KEV vulnerabilities, it's great to know that. So that way, when we have to go in and discuss with remediation teams about how urgent this vulnerability is, we've got all this extra information here that we're using to justify the urgency around these vulnerabilities. So we can see at the end of that process, it's returning us my score. Now, again, this is all the criteria that we've built up that makes sense for this organization, but it's entirely up to you how you would do this for your own organization. The data is there. It's just a matter of applying it in the way that makes most sense. The other function there is to go and take that score and convert it to a priority. So this is where we're doing the weighting. We're saying if it's between 0 and 30, it's a low, 30 to 70, it's a medium, 70 to 110, it's a high, 110 to 140, it's actually critical. Otherwise, it's informational. So that information is what we're going to use, and really to then go in and update that vulnerability and then give it that prioritization that it actually needs. So that's really all there is to it. Again, it's highly recommend looking at Flashpoint's VulnDB if you haven't already. It's an absolutely fantastic service. We've seen this work very well with a number of customers, and you can check out some videos around that as well on our YouTube. I hope this video has been informative and really giving you some ideas to sort of run with and start experimenting on how you want to apply threat-informed prioritization in your organization. So thanks for watching.